Hey there, science fans! Today, we're diving into the fascinating world of electronics cooling. You know, all those cool gadgets we use every day, from smartphones to laptops, generate heat. Too much heat can slow them down or even damage them. That's where air cooling comes in to save the day. Air cooling is like giving your electronics a refreshing breeze. It works by transferring heat away from the hot components and into the surrounding air. Remember, heat always flows from hotter objects to cooler ones. So the air acts like a carpool, picking up heat and carrying it away. Think of it like this. Imagine you're holding a hot cup of cocoa. The heat from the cup warms up your hand. Similarly, electronic components like processors get hot when they're working hard. We need a way to remove that heat, just like we need to put down the hot cocoa to cool our hand. Air cooling is all about keeping things cool and running smoothly. It's like giving your electronics a breath of fresh air, ensuring they stay happy and healthy. In the next section, we'll explore the dynamic duo of heat spreaders and heat sinks, the unsung heroes of electronics cooling. Stay tuned. Now let's meet the partners in crime-fighting heat spreaders and heat sinks. These components work together to keep your electronics cool and collected. Imagine a hot potato fresh out of the oven. You wouldn't hold it directly, would you? You'd use a pot holder to spread the heat. A heat spreader acts like a pot holder for your electronics. It's a thin, flat piece of material, usually made of a good conductor of heat like copper or aluminum. It sits on top of the hot component like a processor and spreads the heat out over a larger area. That's where the heat sink comes in. It's like a radiator for your electronics with fins that increase its surface area. The heat spreader transfers the heat to the heat sink, and the fins allow the heat to dissipate more easily into the air. Think of it like this. A flat sheet of paper won't cool down as quickly as a crumpled one, because the crumpled paper has more surface area exposed to the air. Together, heat spreaders and heat sinks act like a tag team, efficiently transferring heat away from your precious electronics. They are essential components in many electronic devices, ensuring they operate within safe temperatures. But what are these heroes made of? Let's find out! Choosing the right materials for heat spreaders and heat sinks is crucial for efficient cooling. Just like you wouldn't build a house out of playing cards, you can't use just any material to dissipate heat. The name of the game is thermal conductivity, a material's ability to conduct heat. For heat spreaders, we need materials like copper and aluminum. These metals are like the Olympic sprinters of the thermal world. They transfer heat quickly and efficiently. Copper is the gold medalist with excellent thermal conductivity, while aluminum is a close second and is lighter and more affordable. Heat sinks often use the same materials, but their design plays a key role. Remember those fins we talked about? They increase the surface area, allowing the heat sink to dissipate more heat into the air. Sometimes heat sinks use fans to move the air even faster. Choosing the right materials is like picking the right tools for a job. You wouldn't use a hammer to tighten a screw, would you? Similarly, selecting materials with the right thermal properties is essential for efficient and reliable electronics cooling. Now, let's explore the different ways we can use air to cool our devices. Remember the hot cup of cocoa? It cools down on its own, right? That's natural convection. The air near the cup heats up, becomes less dense and rises, carrying the heat away. This process happens naturally without any external force. Natural convection works well for devices that don't generate a lot of heat. It's like letting your electronics cool down naturally in a well-ventilated room. However, for more powerful devices that generate more heat, like gaming computers or data centers, natural convection might not be enough. That's where forced convection comes in. It's like giving your electronics a cool breeze with a fan. Forced convection uses fans to actively move air over the heat sink, increasing the rate of heat transfer. This is like using a fan to cool down a room on a hot day. Choosing between natural and forced convection depends on the amount of heat generated and the desired cooling performance. It's like choosing between walking and taking a bike ride. For short distances, walking might be enough, but for longer distances, a bike will get you there faster. And that's air cooling in a nutshell. We've learned about the importance of heat spreaders and heat sinks, the magic of materials and the power of air movement. Remember, keeping your electronics cool is essential for their performance and longevity.